Here no need to convert it into radian. Why? Because if you convert it into radian, again pi by 180 cancels. Theta will be, SI unit is what? Radian. Now we got in radian 22 by 100, or further I can write it as wheel rotates one time, then it will cover 2 pi degrees, 2 pi radians. The triangle is equilateral triangle. If all sides are equal, we call it as what? Equilateral triangle. They want in radians. So whatever L by R, when you divide length of the arc by radius of the arc, one revolution is 360 degrees. 360 degrees in radians is 2 pi radians. Welcome to the session, dear students. In today's class, I'll go ahead with the chapter Trigonometric functions. So now we have exercise 3.1. We have done problem 1 and sub questions of 1 and 2 and sub questions of 2. Now we'll go ahead with the problem 3. A wheel makes 360 revolutions in 1 minute. So number of revolutions they give, I'll consider it as n. N is 360 revolutions it will undergo. Revolutions. Fine. Then in 1 minute they told. Time is also given 1 minute. Okay. Further, through how many radians does it turn in 1 second? Through how many radians means they want angle in 1 second. This is in 1 second. See, first you should know one revolution means, one complete revolution means it will cover total degree. Total degree is what? 360 degree. So now first, what is the basic? One revolution is equal to 360 degrees. You know, SI unit of, see, they want in radians. How to convert degree to radian? So 360 degree to radian means pi by 180. Pi by 180 if you multiply, so 180 ones are, 180 twos are. So 2 pi in, so one revolution is, if wheel rotates one time, then it will cover 2 pi degrees, 2 pi radians. So now 2 pi radians. So therefore you got one revolution is equal to 2 pi radians. This is first basic you should know. One complete rotation is what? 360 degrees. One revolution is 360 degrees. 360 degrees in radians is 2 pi radians. Now it makes, see, 360 revolutions in 1 minute. So how many revolutions per second you should calculate? So number of revolutions per second is, see, 360 revolutions per minute. So 360 divided by 1 minute. 1 minute means what? 60 seconds. So if I do that, you will get number of revolutions. You know, 0, 0 cancel, 6, 6. So you will have 6 revolutions. So 360 revolutions in 1 minute means, in 1 minute it is, in 1 second it will be 6, 0, 0 cancels and 6, 6, 6 revolutions. So first I calculated number of revolutions. So they told a wheel makes 360 revolutions in 1 minute. In 1 second if you want, so divide it by 60. So in 1 second just 6 revolutions it will do. Now further, angle made in the 6 revolutions. So they want how many radians it will make in 1 second. So therefore, angle made is equal to, for one revolution, so 6 into, for one revolution we have 2 pi radians. For 6 revolutions, 6 into 2 pi, that is 12 pi. 12 pi radians. This is the angle made. I hope all of you understood this. So now in one revolution it will make 2 pi radians. So now 6 revolutions is what? 12 pi radians in 1 second. So therefore wheel makes 12 pi radians in 1 second. I hope all of you understood. So one revolution is 360 degrees. 360 degrees means 2 pi. 2 pi is one revolution. We have 6 revolutions. 6 2s are 12 pi. That's it. Find the degree measure of angle subtended at the center of circle of radius 100 centimeter by an arc length of 22 centimeters. So now they want degree measure of angle subtended at the center. So now say this is the center, and they gave of a circle radius 100 centimeter they told. So this is r is the radius 100 centimeter, and subtends an angle, so it makes an arc. They want you to find arc length L, and theta they want, sorry, it subtends, see, at the center of a circle, radius 100 and arc length, they give arc length is what, 22, arc length is L is what, 22 centimeter. So please understand, if you take any arc is what, part of circle. So this is an arc AB, and this is a center, and this is a theta, this is arc length. We have formula, arc length is what, r theta. Arc length is what, r theta. The length of this arc AB, this is the length of the arc AB, is what, radius into theta. So arc is a part of what, circle. If I complete, you will get a circle. So now arc length L is r theta. What is given? So they give given radius is given. If you read the question, radius they told 100 centimeter, and also they gave arc length L they gave 22 centimeter, and they wanted to find the theta angle. So what is the formula? L is equal to r theta. So theta becomes what, L divided by r. So transfer this, L divided by r. L you know 22 centimeter, r you know 100 centimeter. So both are in centimeter, you can cancel. So 22 by 100. So they want you to find in degree, find the degree measure. So this is in radian. Always when you solve, the theta will be SI unit is what, radian. Now we got in radian 22 by 100, or further I can write it as divisible 11 by 50 radians, but they want in degree. This is in radians, so that's why I don't simplify, let it be. So now they want degree, so theta in degree. All of you know how to convert radian to degree. So theta is equal to 22 by 100 radian. If you want to convert radian to degree, multiply 180 by pi and take pi as 22 by 7. So 22 by 100 into 180 divided by pi. Pi means 22 by 7. By 7 I'll write it on top. So now you can cancel the terms. You can cancel 22 and 22 and 0 and 0, and further you can simplify. What you can simplify? 2 5s are 10 and 2 9s are. So we have into, sorry, here 7 is left out. 9 by 5 into 7 degree, or 7 multiply this, 9 7s are 63 by 5 degree. Now you got the angle. What is the angle you got? You got the angle as theta is equal to 63 by 5 degree divided. So 5 1s are 5, 10, 13, 5 2s are 10, 6. So 12.6 degree. 12.6 degree means this 0.6 you convert it into minutes. So how to convert? So this 0.6 into 60 minutes. You know 1 degree is 60 minutes. 1 degree is 60 minutes. 0.6 is 0.6 into 60. That will become 30. Say 360. Point if you should 36 seconds. So 12 degree 36 seconds. 12.6, when you divide, you will get 12.6 degrees. 0.6 degree, say if it is decimal, you know 1 degree is 60 minutes. 0.6 degree is 0.6 into 60. If you do, you will get 36. So convert the decimal part into minutes. And the basic is what I taught you. 1 degree is 60 minutes. So therefore 0.6 degree is 0.6 into 60 minutes. That will give you 36 minutes. That I am putting it here. So they want you to find angle in degrees. So answer for angle in degrees is what? 12 degrees 36 minutes. Then we have in a circle of diameter 40 centimeter, the length of the chord is 20 centimeter, and the length of the minor arc of the chord. They want length of the minor arc of the chord. So first I'll draw a circle. For this circle, they told there is a diameter. What is the diameter of the circle? 40 centimeter. if you know diameter, what is radius? All of you know radius is half of diameter, that is 40 by 2. 40 by 2 gives you 20 centimeter. And length of the card, so length of card. So let us draw a card. I'll draw card AB, and length of the minor arc, they want L, this part. Now I'll take AB, AB's card AB. Card AB, they gave AB length is how much? 20 centimeter. Radius is also same. Now any circle will have center. So now I'll join this and I'll join this. So now please observe, here to here it is radius, here to here it is radius. These two are same. And this is also same. This is 20 and this is also 20 and this is also 20. What is this triangle called as? The triangle is equilateral triangle. If all sides are equal, we call it as what? Equilateral triangle. Now I got equilateral triangle. So what is the angle? Every angle is 60 degrees. They have not given indirectly, but here I can say AB is same as BC is same as AC, because BC and AC are radii. All are equal to 20. So therefore triangle ABC. What is triangle ABC? Triangle ABC is equilateral. What is equilateral triangle? Equilateral triangle is a triangle in which all sides are equal. And for an equilateral triangle, all angles are also equal. Each angle is 60. This is 60, this is 60, this is 60. But I want angles obtained by the arc. So now they want length of minor arc. Here minor arc is L. So from the diagram, length of minor arc L is equal to r theta. Minor arc AB, arc part, this part AB, that we assumed length L. You know length of arc is what? R theta. And they want you to find the length of the minor arc. R is the radius 20, theta is 60 degrees. You know degrees is not SI unit, so convert it into radians. In next step, 20 into 60. How to convert a degree to radian? Multiply pi by 180. If you do that, 0, 0 cancels. Simplify this. 6 ones are 6 threes are 6 ones are 6 threes are. So allow 20 pi by 3. 20 pi by 3 radians. Sorry, length of arc is centimeter. Sorry. So, but remember, all of you, remember here this will give you 120 degree. 120 degree. Sorry, 60 degree into 20 if you do, you will not get the answer, because theta should be in radian, then only length will be in the given unit. So radius is in centimeter, length also will be in centimeter, but your first task is to convert it into what? Convert this into what? So here, please observe, L is r theta. What is r theta? Radius into theta. So 20 into 60 degrees we got. But convert this to radians. How to convert? Multiply pi by 180. If you multiply pi by 180, 61s are 63s are. So 20 into pi by 3. So finally you will get 20 pi by 3. So arc length is 20 pi by 3 centimeter. Or if you want, you can convert 20 into 23.14 divided by 3 centimeter. You can use calculator or leave it. This is standard. Next, if two circles arc of the same length, so two circles arcs of same length subtends an angle 60 degrees and 75 degrees at the center. Find the ratio of the radius. Find the ratio of what? Radius. So now they told two circles. So in two circles, the length subtended, arc lengths are same. See, one arc, say AB, subtends an angle, say theta. Okay, L. For first circle, the length of the arc, same length of the arc. Same length of the arc means L1 is equal to L2. But two different circles will have two different radii. And theta 1, theta 2. Here R1, R2. So I will say R1, theta 1. You know, arc length is R theta. R2, theta 2. Now they want ratio of radii. R1 by R2 is equal to theta 2 by theta 1. Transfer this to this side. That's it. So the ratio of radii you got R1 by R2 is theta 2 by theta 1. So theta 2, what is theta 2? They give 75 degree. What is theta 1? 60 degree. Both are divisible. Here no need to convert it into radian. Why? Because if you convert it into radian, again pi by unity cancels. So now simplify. Both are divisible by 15. 15 5s are 75 and 15 4s are 60. 5 by 4 ratio of radii R1 by R2. So that is R1 is to R2 is 5 is to 4. That's it. I hope all of you got it. So they have different radii ratio. They have same arc length. Same arc length means L1 arc length of the first arc is equal to length of arc of second length. That is L1 is equal to L2. All of you know formula for arc length. What is arc length? Radius into angle subtended at the center. We'll go to the next question now. Find the angle in radians. They want angle in radians through which a pendulum swings if its length is 75 centimeter and the tip describes an arc. See, first let me draw a diagram. So this is the pendulum. Pendulum will swing like this. So means pendulum is covering like this an arc A to B. Okay, pendulum is covering an arc A to B. This is a suspended pendulum. Pendulum moves to and fro. Do you agree? And it subtends an arc. You can see if I join this, I'll get arc. So they give describes arc length. L is given, and they want, and this is radius. I can say, dear students, in the diagram, this is the pendulum. Pendulum will swing, and because of the swing, it will produce this, and this is the radius. So again, this is also a pendulum comes here to this part, and again it will go to this. So pendulum is moving from one place to other place. This is radius. Here to here is radius. Here to here is radius. So what is conclusion? So they have given length of the pendulum. They have given length of the pendulum. Length of pendulum, that is radius. R, that is radius. What is the radius? 75 centimeter. And they give arc length. Arc subtended, that is L is also given in each case. So this is a pendulum. When it moves, it describes an arc. Arc length, this length is arc length they give, and this is the length of the pendulum. You can see length of the pendulum is the radius. That is the conclusion. Now going ahead, so the angle in radian they want through which a pendulum swings. So the length of the pendulum is 75 centimeter and describes an arc. So just for the first problem, let me draw. So this is a pendulum subtended. This is a center. The pendulum is moving from one end to other end like this and describes an arc like this. This is the length of pendulum. This is 75 centimeter. This is also 75. This is the radius, and it makes an angle theta, and arc length L. What is the L subtended? 10 centimeter. They give, it describes an arc length of this. So all of you know what is L? R theta, and they want you to find what? Angle. So what is theta? L by R. So L by R. What is L? Arc length 10 centimeter. What is R? 75 centimeter. Both are divisible by 5. So 5 2s are 5 1s are 5 5s are 2 by 15 radian. Dear students, here they want you to find the angle in radian. So always when you do L by R, both are in centimeter. Centimeter cancels. When you do L by R, you will get the angle. The angle will be in radian. If they want you to convert it into degree, then you multiply and convert. They want in radian. So whatever L by R, when you divide length of the arc by radius of the arc, you will get angle that will be in radian. So no need of conversion. They want in radian. If suppose if they want in degree, then you multiply 180 by pi. So next. So again the same story. Length of the arc is subtending. So this is the pendulum. Pendulum moves and describes an arc, and the radius is fixed. This is R, and 15 centimeters. This length of the arc is 15 centimeters. L is what? R theta, and theta is what? L divided by R into R comes this side, it becomes divided by, and 15 divided by 75. Both are divisible by 5. 5 3s are 5 1s are 5. 5s are 3 by 15 radians. Same thing again. Theta is equal to, directly I can write L by R, and you know what is L? Arc length. Arc length is 21 divided by 75. So both are divisible by 3, or both are divisible by 3. 3 ones, 21. This 75. Is it divisible? Add this. Yes. See how to criteria. 7 plus 5 is what? 12. 12 is a number divisible by 3. So 75. Both are divisible by 3. 3 7s are 21. 3 2s are 6. And 3 5s are 7 by 25 radian. Next. In today's class, I have done problems on number of revolutions. The basics. Just let me summarize. So let me summarize what we have done. So first concept I taught you is one revolution. What is one revolution? One complete rotation. One complete rotation, you can see this is total angle. In one revolution, we'll have 360 degrees. 360 degrees is what? 2 pi radians. On this we have done. And then we have length of arc length. What is arc length? Arc length L is R theta. Again, this is useful in your physics also. So arc length means what? When you take any arc, it makes a central angle. This is arc AB. It makes a central angle with the center of the circle from which it is a part. And this is theta. And this is L. And this is radius. This is also radius. Then L is what? R theta. And area of sector means the shaded part, that is half r square theta. That we'll see later. So today we have done problems on this. In first session, I taught how to convert degree to radian. So x degrees can be written as x into pi by 180 radians. And x radians can be written as x into 180 by pi radians. Today also we use these two to solve. Just a brief summary, and we have done all the problems. I hope all of you understood what I have discussed. I'll see you in my next session. Till then, session 1 and session 2. Become thorough, revise, and attend my next session. So by this, I conclude angles and measurements. Thanks for attending. I'll see you in my next session. Thank you.